Hello FRC programmers, my name is Armand Smith. I am a part of Team 321, the Robolancers in Philadelphia, Pennsylvania. This video is going to be more or less a tutorial for programming in FRC. I know a lot of our team needs to have like videos available because I know they're not going to study on their own, read books about Java, go on Chief Delphi and look up a bunch of how-to things. So I'm just going to make these videos myself for them to watch and for the rest of the world if they want to. So let's begin. The first thing that I'm going to talk about is, so in our team, the Robolancers, we use Java. This will be a Java tutorial. And the API, or Application Programmer's Interface, which will be the stock methods and things you're going to be drawing from when you code, is only compatible with this IDE called NetBeans at the moment. You can download NetBeans here at netbeans.org, or you can go to usfirst.org/roboticsprogram/FRC/software resources, and then you can click, where is it? General Program Resources. Oh, not that. Getting started with Java. There we go. And it'll tell you how to configure the NetBeans installation. It'll take you to this page, I believe. Yeah, installing the Java development tools. It'll tell you how to download all that stuff, how to download the plugins, how to get all your API set up so that your NetBeans will look like this. This is a new download of NetBeans, so you'll see this like recent projects, install plugins, what's new, all this other stuff here. But you don't really have to worry about that. You can just click to not show it on startup, and this won't be here anymore. So another thing is there's a lot of resources on the US First site. They tell you how to get started with Java. They give you a bunch of different resources for Smart Dashboard using the Net Console, Robot Builder, LabVIEW, Quick Start Guides, Vision Processing. I already said all of these, and other stuff. So if you ever want to check that out, I'll have all these links in the description. So let's start with a new project. And because I downloaded all the plugins already, they will give me a bunch of different options. You see FRC Java, then you have your other project types. But because this is FRC Java, we're going to choose it. And they also give you 4 different types of projects within that folder: command-based, robot template project, FRC application project, iterative robot, and simple robot. Now these all have different uses. It depends on how your team wants to code your robot, but in our team we use command-based because we want to sort of delegate different parts of the code to each member or team, and this will let us do that. So we're just going to click on that. And we're going to name our project. I'm going to name this FRC tutorial, and this would be, you know, your project name. So I know, and at least in our team, we try to name them by year so that we can see our progress. So I can see up to 2012's code because that's where we started. Like actually having it all on like Google Code and having it readily available to us. So I'm just going to call this FRC tutorial, and there's a bunch of other things. We're not going to worry about that right now, and I'm just going to press finished. And now you see there is this project here on the left, and give us a bunch of different folders. If we open up the, I don't know why it just stopped. Oh, here it is. Here's the FRC tutorial. And now you click SRC, which is the source code, and you have access to all these folders with the different classes in them. Now these classes are just templates for what you're going to be doing later. So you have your OI, or operator interface. If we open that, it shows us that this class is meant to create buttons, create joysticks, triggering commands with buttons, things like that. We have our robot map, which we should use for constants, so that all the other classes can use those constants easily, and you know where they all are. You have the robot template, which is responsible for your autonomous command, initializing your robot, and a lot of other things like smart dashboard, using the live window, teleop, etc. Let me close these out. We also have command base, which is what the project is named after. So this again is called command based programming. The idea is to have different commands to run different subsystems. So let's say we had a compressor, we would have a compressor command that maybe toggles the double solenoids for whatever manipulators you're running, or you have your drivetrain, which is getting your different values from your joysticks, or you have your manipulator, etc., etc. So this is what that's going to be based off of. We have an example command here just showing us again how to use the command base. So in this case we have the constructor, we have the commands initialize, execute, is finished, and interrupted, which I'll go over at some other time. And finally we have the example subsystem, which is going to be what your subsystem is based off of. Now each subsystem is a different entity on your robot. So like the drivetrain, your chassis, or the compressor, or you have your different manipulators that are there, a ramp, any kind of manipulator, or wow, I get this out of my face. Any kind of manipulator or entity on your robot. So the easiest thing to think about when you're coding first is to think about what you're going to do before you start coding. Now I can bring up sticky note and just start writing down the different things that you want to do. So this tutorial is going to assume you have a 4-wheel drivetrain, and you have one manipulator, maybe some pistons, stuff like that, and we're going to pretty much go over how you can code all of them, the different sensors you might want to use, things like that, looking into the application programs interface for the API, which is built-in plugin. So let's think about this. So we have a 4-wheel drivetrain. We have one manipulator. Let's say that it is like for the FRC 2014 game, our manipulator for the RoboLancers, we had one singular roller, which was pneumatic powered. So that roller, get this out of here. How do I? Current color scheme. Don't show this message again. Thank you. The roller had 2 pistons. It also had 2 wheels, but 1 motor, which is the most important part of that. We also have another manipulator. So let's say two manipulators. We have a shooter. We have a shooter, which was also 2 pistons, and that's it. So let's start. Oh, another thing. Before I actually begin coding, if you click this, the first symbol that you should have after downloading your plugins. You should see this screen, and if you click here, it says JavaDoc API documentation. If I click it, I can see all the different classes that are in the API. So I can't really zoom in on this, and I'm not sure if you guys can see this, but it ranges all the way from accelerometer to, I don't know what writer is, but let's see, something I do know. You have timers, Talon, which is the motor controller, accelerometer, which is a sensor that measures acceleration. So that's always a good thing. I'm going to be referring to this a lot, and I'm going to go back and forth between me coding and this page here. So let's start. We can start by just starting with a joysticks. So in order to make a joystick object, you just say joystick, and then you name your joystick. So I'm going to call this the drive joystick, or the drive stick, and it's going to be a new joystick. And wait, this takes a parameter. I don't know what the parameters are. I can look in the API here and then find joystick. Wow, I went too far. Joystick right here, and I see that there are two constructors. One is port. It just creates an instance of a joystick at the port, and the other one is port, the number of axis types, the number of button types. That's not the one I'm going to want. I'm just going to want the one that has the port, because our controllers that we use, at least, they're not that complicated. They're just typical Xbox controllers. So, and they're going to be in the first port. So I'm just going to put a 1 here in the parameters. And there's another problem here. We don't have the class for joysticks in the class here. We have to import them. So the shortcut for importing is actually Control-Shift-I, but if you just right click, you can go here and just say fix imports, and it'll do it for you. So that's pretty neat. Another thing we want to do is actually get the joystick buttons. And let's call this button 1 is equal to new joystick button. Now the first parameter is the actual joystick that you're trying to put the buttons on. So the reason behind this is because, like, let's say you have 2 joysticks, and you just put like 1, right? You don't know what joystick button 1 that is. You just know that there's a button, that there is a first button. So the first argument will be the drive stick, because that's the only joystick we have, and the second argument will be the button number. And again, we need to import this, so I'm just going to click Control-Shift-I, and it'll do it for me. And I put S here by accident. So yeah. Well, let's say we wanted more than 1 button, and I didn't want to just copy and paste over and over this code and switch out 1s and 2s. So instead of doing that, I'm going to make an array of buttons. I'm going to call this drive stick. Wow, these caps lock. Drive stick buttons. And I'm going to. It's just going to be there for a second. And let's say I want to make 11 of them. So instead of I want to make 11 of them. Equals new joystick button, and then I have 11 of them. But what are those buttons in particular? You just have a random number of buttons. You don't know what the buttons, where the buttons are, what joystick they're on. So instead of doing that, we are going to create all 11 joysticks pretty much at once. But we need a method to do that in. The best method to do that in is actually the constructor. LIC, OI. Then we have our arguments there. So for each iteration of the integer I being less than, or excuse me, the integer I equal to 0, or 1, let's start at 1. I is less than or equal to 11. I increases per increment. We want to make a new joystick button. So drive stick buttons at the iteration of I. We have a new joystick button. Which will be part of the drive stick. And then I will be the argument. Oh wow, I forgot to put BTNS. But yeah, I will be the same here and here. So like if we have the drive stick button at iteration 1, we have a new joystick button, which is the drive stick's first button. So just plug in 1 for each of these I's, and then do the same for 2, 3, 4, 5, 6, 7, all the way up to 11, and you'll have 11 buttons. It saves us a lot of room when coding, and we'll need that because we'll have a lot of other people looking at our code, and they didn't understand what's going on. So I'm going to comment, create 11 buttons. That's all that does. Alright, so now we've created our buttons. We can move on to make our first subsystem. And our first subsystem will be the drivetrain, because you have to start somewhere. You can't just have a manipulator with no drivetrain. And it's going to extend the subsystem. Now, the reason behind this, the reason behind this is because you see how we have example subsystem here, and it extends subsystem. If we go into our API, we look up subsystem. Subsystem. There we go. So it says here, this class defines a major component of the robot. A good example is the drive line or a claw if the robot has one. All motors should be part of a subsystem. For instance, all the wheel motors should be part of some kind of drive line subsystem, which in this case is the drivetrain. Subsystems are used within the command system as requirements for command. Only one command which requires a subsystem can run at a time. Also, subsystems have default commands which are stated if there is no command running which requires a subsystem. So what that pretty much means is subsystems are the core of command base, obviously besides commands. So when you have a subsystem, it needs to take in commands to use them. And we have a lot of different methods in the subsystem class, like initialize default command, set default command, get current command, and get name, which is a very important one too if you're using the smart dashboard, and get table too. So using these methods and other methods that we create, we're going to make all the motors for the subsystem, the drivetrain. We're going to get commands, and we're going to feed it into that subsystem so that we can use our robot. So here I have an error because I extended subsystem. It tells me if I press Alt Enter, I can either implement all abstract methods, make the drivetrain class abstract, or create a subclass within the drivetrain. I'm going to do the first one. And what that does is that takes in the only abstract method from subsystem, which was init default command, and put it into subsystem into the drivetrain, because subsystem requires you to have that method in order to run. It needs you to have the initialize default command. It needs you to at least have it in there. It doesn't necessarily have to do anything, it just has to be in there. But that's not the beginning of the drivetrain. So I said that we were going to have a 4-wheel drivetrain. Those 4 wheels will be powered by, I don't know, let's say 2 motors on each side. Alright, so that we have direct drive. Each motor is connected to the wheel directly, which is actually not a very good idea, but if you wanted to do it, you could do it. Or you could have like a belt system, but that's something that your mechanical team should already understand and have under wraps. You're just trying to internalize the more electronic parts of the robot, so you can code on them. So instead of saying what motor we have, because that's more of a mechanical entity, we're going to talk about the motor controllers. Now, there are 3 major motor controllers out there. There's Jaguar, there's Victors, and there are Talons. If I look up all 3 of them, which I'm not going to, I'm only going to look up one. I'm going to look up the Talon one, because that's what we use personally in the RoboLancers for a drivetrain. We use Talons. So if I go down to Talon, I can see that, it's a public class. It extends safe PWM, and it implements speed controller. Now I can use the speed controller so that it's a generic motor controller, which is what I'm going to do. I'm going to click speed controller, and it's going to tell me that it extends PID output. You don't have to worry about that. This is the interface for controlling speed, or for speed controlling devices, which are motor controllers, more or less. So they have 4 different methods in them. Get, set, they have 2 set methods and then 2 other methods. Disable, get, and set, which is for getting the actual the speed of the motor controller, setting the speed of the motor controller, and disabling the motor controller if something is going wrong. So, whoops, I'm saying set. I'm going to make 4 speed controllers, and instead of making them assigned objects, there's this thing called unassigned variables that you may or may not have learned of already, but it's pretty much calling an object or a variable and not stating what it is. So if I said x, the integer x equals 2, that's an assigned variable. But if I have integer x and then just put a semicolon right after it, you don't know what it is, but you know that x exists. And I mean, it's very useful in certain situations. But I'm going to use it now, and you'll see why in just a second. So I'm going to have 4 motors. I'm going to call them motor 1, motor 2, motor 3, and motor 4. And now I'm going to just import that in there. Alright. Now, with these motors, there's a very, very good class in the API as well that you can use. It's called Robot Drive. It makes everything a lot simpler, but the problem is that it only works with 2 or 4 motor drives. And if you're a team like us who uses a 6-sim ball shifter, which is a pneumatic powered or pneumatic actuated gearbox with 6 sims, or with 3 sims in each side, you're not going to be able to use this class. So you can see here it says this class is a utility class for handling robot drive based on a definition of the motor configuration. This robot drive handles basic driving for a robot. Currently 2 and 4 motor standard drivetrains are supported. In the future, other drive types like swerve and mechanic might be implemented. Motor channel numbers are passed supplied on the creation of the class. These are used for either the drive function instead for hand creative drive codes such as autonomous, or with the tank arcade functions intended to be used for operator control driving. And it has its own set of functions that we can look at some other time, but this episode won't be very focused on that. It'll just be focused on you getting all the variables you need, where you need them, so that you can use them on your robot. So let's start that up as well. Robot drive. We'll call this drive standard, and we'll implement that into the code. Now, because these are all 5 of these variables are unassigned variables, you have to assign them somewhere. Where I'm going to assign them is in the constructor, and there will be a conflict when I code this constructor that I will handle by using another stock Java keyword, and you'll see what that is in a minute. So if I say public drivetrain, and I have the motor 1 is equal to new speed controller, and I don't remember what the speed controller's arguments are, so I'm going to look at that. Speed controller. Speed controller. Its arguments actually doesn't have any. That's different. Talon. Oh, that's right. I can't actually call a speed controller. I have to call a Talon instead, which is the reason why I made this an unassigned variable. And I'll explain that in a second as soon as I get these. Where's the Talons? Oh, here, I'm already on it. Got the slot and the channel. Let's call this 1. Alright. Now, the reason why I made the speed controller an unassigned variable is so that it can easily adapt to what kind of motor control it is. So I could actually, instead of having a new Talon 1, I can have a new Victor 1 or a new Jaguar 1, depending on what motor controller we're using at the time. And sometimes our Talons break, and we only have Victors available to us, so we'll switch out 1 to be a Victor. And let's say I had all of these. Let me actually just copy and paste. Two, 3, 4, 3, 4. Alright, so let's say I had the third one, it broke down. And let's say I had a Victor now. It would still work in the code as long as I implemented it. But if this said Talon, I would get an error. You see? It would tell me that, you know, Talons aren't Victors, which is obvious. Talons are not Victors. But a Victor is a speed controller, and a Talon is also a speed controller, which is why this works so well. But these are all Talons, so let's not worry about that for now. And we're also going to have our drive standard. Drive standard is equal to new robot drive, and it takes in the arguments of the 4 speed controllers that it's using for the drivetrain, or the 2 if you have 2 motors for whatever reason. So I'm just going to put them all in one by one. And now that's done. So another thing that may arise within your team is a small miscommunication problem. Let's say your electrical team, they put the ports of the motors not in 1, 2, 3, 4, but in 2, 3, 4, 5. Now, instead of going to the drivetrain and doing this, you can easily make a variable in your robot map that will be able that you'll be able to do this with. So, in the robot map, we can make as many constants as we want. This entire class will be just a class of constant variables. In order to make a constant in Java, you type public static final, and then whatever type of data it is. So in this case, it's an integer, and we'll say this is the motor 1. And we'll also denote that it's a constant by putting k, and we'll set it equal to 1. Now, I haven't used any of the static or final keywords yet, and I just want to go over what those 2 keywords mean. Static pretty much means that it's global. All the classes in the project can see it. And public also means that all the classes in the project can see it, but it doesn't necessarily mean that you can use it. Static lets you actually use it. It's a global variable. Final means that once you initialize the variable, it has to be that number. You cannot change it at some other point, so I can't just go at the bottom of the code and say, okay, kmotor1 is now equal to 2. Well, it can't be equal to 2 because you finalized it. You made it equal 1 when you started it, so what are you doing? That's what this final and static keywords mean. I'm going to do this for the other 3 motors. Whoops, 12, 3, 4. Alright, and now that's done. Now, in order to get these values into my motors, I just have to say, okay, where is the value held at? Well, it's held in the robot map, and it's kmotor1. And now it immediately it automatically imported it for me, so I don't have to worry about pressing Control-Shift-I. It just did it for me because it's in the same project. And I'll do the same thing for the other 3 talons. Wow, I just messed up. 4, 3. Alright, and now we have all of our motors set up. We have a drive, our robot drive set up. We have our class pretty much set up. We have our robot map set up. I'm just going to save this now. I can delete this example subsystem because it's in the way. Safely delete. Oh, fractor. I can also delete this example command. Or actually, no, I'll keep the example command for right now. Get this out of here. I shouldn't have done that. This is annoying. Alright. So, another thing. You remember how I said that static lets all of the different variables you have in that class be used by every other class in the project? Or at least where you let it see it. So in public it would be in the whole project, and protected it would be only in that folder. In order to effectively have an autonomous code for later, or any other commands that will use these motors, or maybe the actual robot drive objects, you're going to also have to make them public and static. Public and static. And we can do the exact same thing for the joysticks when we started making them as well. So, that's all the time I have for today. Thanks for watching. Next episode will be on how to make commands in the drivetrain, a init default command, how to get your different values from your joysticks and translate that into driving a robot. So, for now, I'll say goodbye, and I'll see you next time.